I would like to bring few things about the Telangana State Center. I'm proud to announce that the Telangana State Center is the only center out of 125 centers of the Institution of Engineers, India, which has been awarded ISO 9001 2015 certificate, and it is the legacy of Restwell Nizam, the Hyderabad State Center, formed on 28th August 2016, and it has got a total members of 10,000 plus on its rolls, and more than 19,000 non-corporate members in its fold. And one of the most active center of the Institution of Engineers is engaged successfully in translating the objectives of the Institution of Engineers, vision and mission of the Institution of Engineers. And within its formation of 2-3 years, it has bagged already 3 times Best State Center Award. It is the remark or reward for its performance of the Telangana State Center. And Telangana State Center has been playing very important role in dissemination of information and engineering and contemporary technology, bringing industry, academia, experts and professionals together in the same platform. And I am also proud to announce that the Telangana State Center is the only center during November and December 2022, which conducted 2 conventions on the breakthrough technologies. One is on 5G technology impacting the industry and society, creating new value. And another convention in mechanical engineering, that is on advances in battery technologies for electric and hybrid vehicles. Both are very prime and prominent conventions of Institution of Engineers, and it was our privilege, and we are the headquarters has got such a faith in Telangana State Center and awarded both the conventions, and which were successfully conducted at now. The Telangana State Center is regularly organizing international conferences, national conventions, all India seminar, conferences, workshops, and roundtable conferences and panel discussion throughout the year, almost an event every 4th day. And also proud to bring you to knowledge that the Telangana State Center, in association with the Safety and Quality Forum of New Delhi, has conducted during the April Safety and Quality Awards and to the industry and also both manufacturing and services, and it had good response from the industry, and it was a successful event conducted at Hyderabad. And I am glad to inform that the Telangana State Center has been regularly organizing 20 endowment lectures every year on the birthdays in the honor of the eminent engineers like Engineer V. Subbarao, Engineer M. Tirupati Reddy, Professor K. Gopichand, Dr. J. Purushottam, Engineer G. Prabhakar, Engineer Poka Krishnamohan Rao, Engineer J. V. Subbarao, Engineer T. Hanumantarao, Engineer A. P. Ranganatha Swamy, Dr. S. Raghavachari, Dr. Narla Tatarao, Engineer Matur Gopal Rao, Engineer Gurram Kotreddy, Engineer Attur Venkateshwar Rao, Endowment Lecture, and Engineer R.L. Raju, and Dr. John A. Murray, Dr. N.V. R.L.N. Rao, Engineers L. Venkatakrishna Iyer, K.V. Srinivas Rao and M.L. Swamy Endowment Lecture, Dr. A. Ramakrishna Endowment Lecture, and Engineer I. Basavaraju Endowment Lecture. I take this opportunity to say a few words about the veteran eminent engineer, late engineer A.P. Ranganatha Swamy. He was born on 27th July 1911 at Rajampet, Kadapa district, which is in Andhra Pradesh now. He combined himself the rare qualities of high technical competence, good organizing capacity, and strive hard to uphold the dignity of engineering fraternity and the profession. Engineer A.P. Ranganatha Swamy studied first standard at Kadapa, where his father was Tahsildar, second standard at elementary school, Dhavaleshwaram, and from this third onwards intermediate to at Vijayanagaram. Engineer A.P. Ranganatha Swamy did his BE Civil from the world-renowned Gindi Engineering College, Madras, during the year 1929 and 1933. He did his practical training during the construction of the buildings at Andhra University when Dr. Sarvepalli Radhakrishnan was the Vice Chancellor of Andhra University at that time. From 1941 onwards till his retirement, Engineer A.P. Ranganatha Swamy was in government service, first in Madras Presidency and later in Restvale, Andhra Pradesh. Engineer A.P. Ranganatha Swamy worked at Polavaram from 1945 to 1949 in the Ram Prasad Sagar Investigation Subdivision. It is here that A.P. Ranganatha Swamy held an intimate contact and made lifelong friendship with other engineers who worked along with him. Sri Vasireddy Suryanarayana, Sri P.T. Mallareddy, Sri M. Venkatrao, Sri N.V. Chalapati Rao, Engineer A. Kameshwar Rao, and from Polavaram he was transferred to Tungabhadra Canal and worked nearly 5 years there. He was promoted as executive engineer in 1953 and again posted to Dhavaleshwaram in 1954. Sri Tangutori Prakasam, Chief Minister of Restvale, Andhra Pradesh, laid the foundation for Krishna Barrage on 13th May 1954. Sri A.P. Ranganatha Swamy was transferred to Vijayawada Krishna Barrage Division. It is here A.P. Ranganatha Swamy showed his capabilities as engineer of high caliber, viewed with great common sense, facing many hurdles with the unpredictable vagaries of Krishna River. Such was the confidence of the then Chief Engineer Irrigation, Sri L. Venkatakrishna Iyer, an eminent engineer of the exemplary character who was devoted to his duty. Late engineer A.P. Ranganatha Swamy was transferred in 1959 to Nagarjuna Sagar Dam. Construction Circle, 1963, promoted as chief engineer, Nagarjuna Sagar Dam. He succeeded the soft-spoken Sri Jafar Ali, chief engineer, who retired. As the chief engineer, he continued to lead from the front by virtue of his redoubtable expertise, skill, and ability. Through discussions and his co-engineers at every stage, and thereafter giving clear-cut instructions, Sri Ranganatha Swamy used to get work executed and completed on time with quality. Late engineer A.P. Ranganatha Swamy was unassuming, free of status conscious, easily approachable to one and all with a simple, sympathetic glance at times of distress. Late engineer A.P. Ranganatha Swamy retired on July 27, 1966, but was given extension of 3 years consecutively to 1969 by the then Prime Minister Srimati Indira Gandhi. Visited Nagarjuna Sagar Dam and was full of admiration for seeing the cascades of water flowing the dam and praised the engineers at work. In August 74 to 79, he was the chairman of AP State Irrigation Development Corporation, and during this period, many underground water resources were tapped throughout the state, which received high appreciation. Engineer Ranganatha Swamy joined as associate member of the Institution of Engineers in 1951 and full member in 1965. From 1982, the fellow of the Institution of Engineers. Engineer A.P. Ranganatha Swamy was chairman of the Nagarjuna Sagar Local Center, served as a number of expert committees by the government, Godavari Barrage, water resources, rationalization of water resources. From time to time, his retirement till 1994, he was attending the arbitration work between department and the contractors. He is closely associated with the number of social organizations and rendered human services. At the efforts of retired Chief Engineer R.S.N. Murthy FI and the Restvale Andhra Pradesh State Center of Institution has kindly taken up the responsibility of arranging an endowment lecture on 27th July every year in the memory of great engineer, coinciding with his birth anniversary by distinguished engineer in honor of late A.P. Ranganatha Swamy. The endowment lectures are being delivered by people of high eminence with considerable professional experience to throw light on important emerging topics of the day's relevance. Today, Telangana State Center has arranged Engineer A.P. Ranganatha Swamy 26th Endowment Lecture on real-time urban flood modeling using ultra sensors and geospatial techniques by the Professor Gopal Naik Garu, Professor of Usmania University College of Engineering. And since I know we are all anxiously awaiting to hear his talk from this eminent speaker, I limit myself and hope that you all will enjoy the talk. On behalf of the Telangana State Center of IEI and on my own behalf, I once again extend a hearty welcome to the eminent speaker, Professor Gopal Naik Garu, and also, of course, I have not mentioned at that time, Subbireddy Garu, who is in London now, is also present on the. We are proud of you, sir. Even you are out of country, you are participating in all the program, and all of you to this important event. I once again pay my tribute to the late eminent engineer, A.P. Ranganatha Swamy Garu, and for his great services to the humankind. Thank you, one and all. Now I request Professor Dr. Ramna Naik Garu to kindly introduce today's chief guest and our eminent speaker to the to the august audience. I request Ramana Naik Garu to
Thank you, Chairman. Thank you, Chairman sir. We are very happy to introduce our today's chief guest, Professor M. Gopal Naik FIE, Senior Professor and Incharge Chief Engineer also. Dr. M. Gopal Naik is working as a Professor, Department of Civil Engineering, University College of Engineering, Autonomous Usmania University, Hyderabad. He graduated in Civil Engineering from University College of Engineering, OU, and obtained Master's degree Civil Engineering with a specialization of Water Resources Engineering in 2001 in OU only. He obtained doctorate from PhD in Civil Engineering from the prestigious Indian Institute of Technology, IIT Bombay, in the year 2009. Before joining Usmania University, Dr. Naik worked as associate lecturer in GMR Polytechnic, Srisailam, Andhra Pradesh. From 1996 to 98, he joined in the service of university in 1998 as an assistant professor, working in the civil engineering department since 2012 till date. His areas of specialization are water resources and environment engineering, geospatial techniques such as remote sensing, geographical information system (GIS), and global positioning systems (GPS) applications in civil engineering fields. Urban planning and development, urban watershed modeling, construction engineering, and management building information technology (BIM) application to the civil engineering field. Dr. Naik has also been awarded to prestigious Telangana State Best Award given by the Government of Telangana in 2020. And another prestigious award, Engineering Year Award 2020, awarded by the Government of Telangana and Institute of Engineers India, Hyderabad. Previously, he has been awarded the prestigious Telangana State Engineering Award in 2019 by the Government of Telangana and the Institute of Engineers, Telangana State Center, Hyderabad, on occasion of Telangana Irrigation Day. He has also awarded another two prestigious awards, Best Faculty Award 2019 in 8th Science Engineering Technology Awards in Bangalore, and prestigious Distinguished Faculty Engineering 2017 awarded in the Center for Advanced Research and Design, Venus International Foundation, Chennai. Dr. Naik has been awarded prestigious Spark Major Research Project by the Government of India, MHRD Spark Project with 74.38 lakhs in collaboration with the Texas A&M University, USA. And the area of research is planning to development of a climate resilting water sensitive urban areas designs, a case study of Hyderabad Metropolitan City, another major project sanctioned by the Department of Science and Technology, DST, Government of India, served project in worth of 40.135 lakhs, have been awarded in the academic year 2018 to 2021. And area of research is sustainable development of urban stormwater systems by considering climate change in urban impact. He has been also completed two research projects, DST, NRDMS, major projects with worth of 15.15 lakhs sanctioned by the academic. Guided more than 65 postgraduates and 4 doctoral awards by the university under the able supervision. Apart from this, Dr. Naik has also guided 8 PhD scholars at present worker under his supervision. He has published more than 75 research articles in the national and international journals and conference proceedings, and also presented his research papers in international platform. Dr. Naik has visited many countries like Italy, France, Malaysia, Kuala Lumpur, Singapore, United States of America, USA, Los Angeles, China, Beijing, Thailand, Hong Kong, and United Kingdom. Dr. Naik has field of various administrative positions, university administration level, college level. Presently, Dr. Naik holding the post of Professor of Civil Engineering and also Chief Engineer, Usman University and Nodal Officer Academic Tech 3, formerly Head of Department, Usman University, Hyderabad, and Director of Infrastructure, Usman University Special Officer Centenary Celebrations 2017-18, Prestige 100 Years Celebrations, and Nodal Officer Academic Tech 2 and 3, Joint Director of Academic Cell, Usman University, Special Officer Infrastructure at University College of Engineering, Chairperson Board of Studies for Civil Engineering for University level and University College of Engineering Autonomous. Further, Dr. Naik has been appointed as the Board of Administration and also as a member of governing bodies, he affiliated to College of Usman Universities. He was appointed as a reviewer of the peer-reviewed journals such as Elevation Journal of the Hydrology and Journal of the Hydro Environment Research and many other journals. And Doctors IERED Conference and Journals. And last year in the flood, we conducted a roundtable conference on his project DST near the Begapet Higher Public School. Our Vinod Kumar sir, chairman, also come to the conference. And particularly my friend, Professor Gopal sir, welcome sir. And he helped a lot of our, not only Usmania JNT, all of engineering students. Sir.
Thank you. Thank you, Dr. Professor Ramana Naik Garu. I also invite and welcome Dr. G. Rameshwara Rao of Engineering Staff College of India, and also Narayan Rao Garu and others who joined later, and also others, Sai Ramana Garu and all. Sir, I request Professor Naik Saab, so kindly you can proceed with your talk, sir.
Yeah, good evening to all eminent personalities who are here. So thank you so much, sir, for elaborated introduction, and I also thanks Professor Dr. Ramana Naik Saab and Chairman Garu for giving the opportunity to deliver the talk on the present and burning topic on that. So my PPT is visible now, sir?
No, sir. You have to share the screen first.
Oh, I shared actually. That okay.
Good, thumbs up.
No, first it came. Initially, it came. I think it is off. You please check one sec.
Yes, sir. Yes, sir.
एक बार चेक कीजिए डॉक्टर गोपाल सर. Yeah, now, yeah.
Now is okay, sir?
Yes.
Oh, no, again it has gone up, sir. You have to share.
Okay.
Yeah, now it has come.
Yeah, come.
Yes,
Now it is. Now you
okay?
can proceed.
Yeah,
it is visible, sir.
Yeah. So thank you very much for giving opportunity to deliver a talk on real-time urban flood modeling using the geospatial techniques and ultrasound sensors. It is pleasure to be a part of the Institute of Engineer as a FIE, and it is my pleasure as a Professor of Civil Engineering Usman University. I am working on that. I can give a few minutes talk on this topic, which my PhD students and my research scholars are working in this topic. So I am today delivering these talks and covering the brief about my outline of urban presentation is urban water cycle, urban flooding, causes of urban floods, and real-time flow monitoring devices and urban flooding modeling. So everybody knows that the concept of urban flooding and the watershed management and urban drainage systems and hydrologic cycles, how the circulation of waters and what is the precipitations and runoff and the rainfall runoff activities and infiltration and percolation and the surface flow, we can see as the urban water cycles, how it evaporates and transpirate and then again precipitate and create on that. So this is the situation generally we have seen in the different cities. Almost all the cities we are experienced by there is urban floods last few decades. Urban flooding is a significant different from the rural floodings, and urbanization leads to develop the catchment with increase in flood peaks from 1.8 to 8 times of flood volumes by the 6 times in natural disasters management. So these are the cities mainly we have seen last couple of years and a few decades, frequent flooded cities, majorly most of the South Indian cities, Hyderabad, Bangalore, Chennai, frequently is flooded compared to the other Delhi and Guwahati and Mumbai. So these are the cities which are effectively or badly affected by the Hyderabad, Bangalore and Chennai and Mumbai, these cities, based on the extreme rainfall events. Sometimes because now we are seeing the frequent rainfall events, the extreme rainfall events which occurs in the more than 10 centimeter per 24 hours or per day. So the causes of urban floods mainly classified the two types, direct factors, indirect factors. So then the direct factors are global climate change and urbanization, which affected more on the urbanization to improve to growth of urbanization and to reduce the drainage capacity of the channels and river encroachments, and the major in the construction in the tanks. So the indirect effect are improper adequate drainage system and improper solid waste management. So these are the cities which are mostly getting affected year by year. So with the direct change in weather patterns, heavy rainfall events in direct effects, global and development encroachment of floodplains causing by loss of natural drainages, and continued development of redeveloped higher density land use, and increase the impervious areas day by day, year by year, and increasing the urbanization and reducing the carrying capacity of the channels, which leads the heavy urban floods. The direct factors, climate change, we have seen the last couple of decades that the climate change and global warming is affected and changing their patterns and increasing the temperature from 1 degrees to 2 degrees in average, and that was affected by the whole system, and also it's affecting the greenhouse effects. So global warming and climate change, a global gradual increase of earth surface temperature and long-term change of global and weather patterns. These are directly or indirectly affecting the atmospheric parameters and the climatic parameter. These atmospheric and climatic parameters which are affected and suddenly changing the behavior characteristic of those parameters and occurring these frequent rainfall events. The change in weather patterns leads to heavy rainfall. So sudden formation of cyclones or hurricanes. So these leads to form of hurricanes, and it leads the increase of temperature and the forest fire burns, the pollution, transport, the increase of heavy transports on road, and then the carrying capacities decreases day by day. So these are the major causes to increase the pattern of the rainfall, heavy rainfalls in the different areas. The how higher temperature causes extreme rainfall. So higher temperature is caused the more heat from the sun causes greater evaporation and heavier rains and more moisture in clouds. These will lead to the sudden rainfall in a shorter duration with high intensity rainfall in a frequently. So urbanization, see the last 10 few decades after 90 and before 90, there is a drastically changing in urban cities. Most of the urban first capacity cities and second level cities are increasing drastically. The urbanization growth, population growth, and reducing their carrying capacity, holding capacity of the rainfall events, rainfall and quantity of the rainfall, and that effect the directly or indirectly leads to the urban floods. So urbanization or man-made urbanization, so it increases the floodplain encroachment, leads to flood encroachment and continued developments. So natural loss of natural drains and increased impervious pervious areas and decrease the impervious area by roads, roofs and paved surfaces. So the loss developed regions, so last few decades in Africa, Asia, including Japan and Latin America and other Caribbean and Malaysia and Micronesia, these are the few countries which are drastically changing the urbanization. So see the graph with 1952 to 2020 or 2030, it is rising in the vertically in a linear direction. When the million of population increases, the year-wise increasing population drastically, urban population, and decreasing the after 2010. There is a drastic decrease of rural population. All the rural population is migrated to the urbanization and increase the urban population, and those migrations are created their shelters in near banks, river encroachment, tank encroachments, and the areas, open area, wherever the infiltration capacity drastically it reduced the rain infiltration and percolation capacity of the surface. So major holding capacity of the water is subsurface. So when the subsurface is covered with the pervious material, then there is a drastically decrease in the water holding capacity in the surface, subsurface, and most of the carrying capacity is only run as a converted into the runoff water. So the urban heat islands increase the rainfall rate around cities in 48 to 160, 116% as per the NASA's report. So the wind interact with the urban induced convection and to produce the downwind rainfalls that leads to the sudden rainfall events and heavier sudden rainfalls with a high intensity rainfall with shorter duration. So causes of heat islands: the material construction, concrete, asphalts, lack of vegetation, lack of evapotranspiration activities to affect the cooling, then the waste energy from air conditioners, cooling systems, then the polluting the surfaces, air pollution, water pollutions, and the tall building block surface, heat from radiating into the relatively cool night skies. So these are the factors which are influencing on the surface and creating the more and more impact on the atmosphere and the climate. And then these type of sudden impact or sudden shorter duration, high intensity rainfall flood is occurring with the shorter distance, shorter zones, and creating the flash floods. The indirect factor with the poor drainage system, that is every city is experienced. There is no proper maintenance of the urban drainage system. There is no proper maintenance of the stormwater drainage system and the sewerage water drainage system. So most of the cities, they are maintaining both, combinedly releasing the water, where stormwater and drainage sewerage system is flowing combinedly, and all the sewerage systems which are dumped in the waste material in the sewerage, that was occupied by the all the stormwater drains and drastically reducing the carrying capacity of the stormwater drain capacities. So real-time flow monitoring devices. So here it is, there are electronic devices which use weather and the water level sensors, remote monitoring system, real-time alert sensors. So in Hyderabad, I have installed the two ultrasonic sensors, flow monitoring system, real-time flow monitoring system, to assess the flood risk assessment or flood water levels. So here current scenario, water supplies from the distant sources to the cities, rapid development in water supply sectors in that. So development of the corresponding sewer systems is very slow, and development along the natural drains are very poor, and there is no maintenance in the drains and occupants. All the, you see this, the last picture, the drain, above the drain there are the construction of houses. There is slab, and in the slab there is a house constructed, and people are living on the across the drain. So then this is the area where this is the situation is happening each and every cities. So hydrological effect on urbanization. So before development and after development. Before development, all the surface, urbanization surface is a natural surface where there is a vegetation. Vegetation will be laid on that, and each vegetation which has a holding capacity, high holding capacity of the water infiltration, water surface runoff capacity. So reduce the runoff and increase the infiltration. So, but when after development, because all construction areas will constructed without proper drainage system, and total surface, whatever the rainfall occurs on the surface, will drain towards the at the end, and then it will flash flood at the low-lying areas. So this frequently we are observing. So because of imperviousness, drainage slopes, direct runoff, and decrease in evaporation, decrease in charge, and base flows. So problem and its challenges now we are facing. So downstream flooding caused by excessive upstream flow, and these by this because totally remove. The problem is only majorly there is no proper drainage system, there is no proper maintenance of drainage system, there is no proper creation of drainage system with their from upstream to downstream. Convention solution, the large relief of sewer and modify the upgrade all the existing drainage system should be desilting. It should be modified, calculate the risk impact study of the upstream area, and identify the quantity of discharge with the various rainfall intensities, and create the drains with their carrying capacity of last 100 years and next 50-60 years. What is this? The carrying capacity should be flow into the proper drainage system. Otherwise, again, create the radial drainage systems where the more maximum water carrying capacity from upstream to downstream. So here the hydrograph, see the schematic hydrograph downstream flooding areas, because there is a carrying capacity of two drains, upstream capacity drains, if three units, left drain and right drain, if carrying capacity 3 unit left and 3 right, then jointly organic combined flow is 6 unit in a greater than downstream system capacity, where downstream capacity is only capacity 4 unit, but the carrying capacity from upstream is 6. Then the other 2 unit, excess unit, will create as a excess flood. So how to remove this flood or how to drain up this flood? What is the sources? So that each and every catchment, whole area divided into sub-catchment or sub-segment areas, or grid-wise, or the segment-wise, and calculate the carrying capacity and the total runoff capacity of the sub-areas, and identify the total quantity and integrate with the next downstream carrying capacity and identify what is the excess carrying capacity. That how to reduce that carrying capacity, how to evaluate and how to adjust that excess 2 unit carrying capacity. That solution should be required by the agency organizing agencies or existing agencies. So hydrograph, it shows the schematic effect of flow control and attenuation, the storage capacity of 3 unit from upstream, attenuation, and capacity of 3 unit from downstream. So then again it join with the 2 unit capacity. Then again it divide the 2 units in the different capacity, allow them to infiltrate into the surface by creating the rain gardens, by creating the drain surface drains or surface gardens where the existing availability are there, or tanks or holding capacity of the tanks, hold the 2 unit, excess 2 unit, and release the only available 1 unit, 1 and 1 unit, 2 unit, and release only 4 units which are capable to carry by the downstream. So this is the concept is required for every cities which are holding capacity, and the drain capacity and the excess runoff capacity should be matched with the upstream side and downstream and calculate thoroughly. So the requirement of flood early warning system. Rainfall is a highly variable in area and time. Network of rain gauges required which can measure and transmit the rainfall in real time to manage authorities, because rainfall is varying time to time and space to space. So every phase, earlier there is a calculation every 2 kilometers or 3 kilometers there is a rainfall, a rain gauge station should be installed. But now in Hyderabad, no, there is 5 kilometers also, there is no proper rain gauge system to measure the rainfall quantity in the particular zone. So then how to calculate what is the quantity of rainfall it coming from upstream to downstream? So there must be minimum 2 kilometers or 1 kilometer is holds good. But if required at least 2 kilometer radius, there is a each and every location rain gauge station should be installed and measure the rainfall, and then identify the what is quantity of runoff is coming from upstream that particular catchment, and releasing what is the quantity of rainfall we are releasing through the drain, and that has to be calculated and assessed in the rainfall, and maintain that existing as well as and the excess runoff. The flow gauge and channel drain slope data are enable the computer models. These data should be analyzed or simulate by using the softwares or database management system which are available in the system. So here I did in the HECROS a model which can calculate the total capacity of the runoff from upstream to downstream. So here the flood and water level forecast, the catchment area, catchment data, precipitation data, and discharge data. These are the input parameter is required. What is the catchment? What is the rainfall occurs on that particular catchment? And what is the quantity of discharge coming from that particular catchment? So then we can simulate by using, there are simulation models, many simulation model, HEC-HMS, HEC-ROS, PCSIM, SWAT model. So many models are available in the system. So you can simulate that, identify the quantities, and then create the hydrograph. So then you create hydrograph, the simulated hydrograph, and observe here. So then the other additional parameter, then you add into that additional parameter, river geometry, size, shape, depth, width, height. What is the channel geometry, river geometry, bridges, and culverts? These are input that are required by the HECROS and PCSIM. So there we can sim the hydraulic simulation. So first we need the hydrological simulation where we considering the hydrological data, surface catchment area, catchment slope, catchment discharge, catchment runoff. So hydrological. Then we can calculate by the hydraulic simulation where we can calculate the discharge, depth of flow, velocity of flow, and these are the hydraulic parameters which can calculate by using the standard softwares which are available, PCSIM, a personal computer-based stormwater management system, HECROS hydrological engineering unit, HECROS hydrological models, and we finally calculate what is the depth of flow carrying by the river, so that carrying by the channel, carrying by the nalas, and then what is the flooded excess water, what is the capacity of the nala, what is the excess capacity of the nala, we can calculate on that. This is the first my sensors installed in the Khairatabad flyover near the 20 MLD sewerage plant in Khairatabad near the PV Narasimha Rao statue, in the Ambedkar statue, their flow gauge installation at Begumpet and Balkampet Nala. So these two nalas we install here and measuring the water level every minute, every second. Per day 1440 readings we are getting, 1440 readings every second level or minute level we are getting the water level, how increasing. Here it is the end point of that outlet point, and what is the upstream nala, where from starting point to ending point, how much capacity of nala is carrying the water flow, that is we are measuring in that. So in this presentation, I am concentrating this data which are presented here. Two nalas, one Balkapur Nala is near Khairatabad flyover. Other one is the Kukatipalli Nala, where another sensors installed in Katta Maisama Begumpet flyover near, and that two sensors we installed luckily just before the 2020 floods, and all the data from 2020 June to till date, we are capturing the data every second, every minute data. What is the water level coming from these two nalas? And also we identify Picket Nala, but the sensors are installed only two nalas, and this project is measuring devices provided this data. And these nalas we are calculated for identified based on the survey of total station survey we did. We identified the base station, base value elevation by total station mean sea level, and then with slope we identified what is the particular slope of location, and we are calculating flow at these two locations, and we are measuring by using these ultrasonic open sensors. So these sensors, a component of sensors are ultrasonic open channel flow meter sensors. It's working with the GPRS data loggers. So it is a radio waves, this later radio sensor data loggers. So it captured the data in the sensor, through sensor to the data logger. From data logger to the SIM card, we install a SIM card there. From SIM card to this data will stored in a servers where we install the cloud servers. And there are accessories required, UPS, the surge protection and power supply module and cable, everything. So ultrasonic open channel flow meter is used to measure the real-time flow level in channel. So every minute, every second, today what is at present data will receive in a mobile. So that we can assess, we can model, we can alert them. If the one data is receiving every minute, and what is the carrying capacity, what is the flow coming from upstream, then automatically that we can send the alertness to the downstream areas. This is a flood is coming, so immediately you evacuate or alertness. This system is very much useful for the agencies who are managing the flow, the Metro Water Works system, this Hyderabad Metro Water Works, GHMC, Revenue Department, Lakes Department, Musi River Board Management. These departments should have such type of mechanism and calculate the data at every location, every 1 kilometer. If we install the sensor, calculate data, and then alert the people, then we can avoid from the human loss and also the economical property losses for that. So data logger continuously logs the data in the local memory and also send the data to the server using SIM card data. So real-time data can be viewed in web portals, mobile app along with the trends. Historical data of 24 hours emailed in register users every day from, we can calculate from 8 a.m. to 8-9. This is a system will work, how the electronic sensors, how the ultrasonic sensor will work. So sensor installed at the nalas just above the nala at the for 10 feet or 5 feet depending availability of the nala. So sensors is allowed, 2 sensors we install at that, and 2 sensors connected to the data loggers. The data logger nearby power room. So we connected the same sensor cable with to the GPRS data logger. From data logger through wireless system, through SIM card, we are connected to the server. So server every minute recording, from the server it send the alertness to the mobile. There are who are registered mobiles in the data server, those people will get regular information minute to minute. See that this is the graphs we give in mobile. So see the 2 graphs are there, point wise, the minute wise data we are getting. So one is the blue line is water level and red line is the flow level, flood level. So water at the base level and flood level, what is the data is coming. So measurement in open channel. So generally this measurement is taken place by using the Manning equation. So roughness, generally flow rate, Q discharge calculated by the area into radius of the hydraulic channels and surface slopes by N. So this calculating by using Manning formula, and the surface slopes, cross-sectional area, wetted perimeter, length of uniform, and we can calculate that. Roughness coefficient generally we can take based on the standard patterns by the literatures, which are Ventichow and other, which the channel is a paved channel or vegetative channel or rough channel or slope channel. Based on that, we can consider the Manning chain value in the different value with the based on the practical situation, field visit and field data. So channel parameter in Begumpet. So we are calculating in the Begumpet is parameters which are flow water level, discharge, Manning coefficient which are given, channel data and slope channel is given, and water, and the total discharge we are calculating, what the flow depth and discharge we are calculating every minute in the both the Khairatabad Nala and as well as in the Kukatpalli Nala. So this is the 2 values we are receiving from the data loggers in the water flow in a meter cube per second, 2.342 meter cube per second. That particular graph which can be calculated in the 19th February 2021 data, which day time also we can measure in that. So here you see that this is the graph flow data details. We can measure here water level. The second floods we are giving water flow rate. So 0.68 meter cube per second, and the water level is 0.14 meters. It is, this data is generated at 19th January 2021, 9:48 a.m. So like that, every data, every minute we are generating this data and manually. So this data is the input to the model. So model generated by rainfall. So then we can simulate the model by using hydraulic model development. So record rainfall event catchment characteristics using HMS hydrological model, and the catchment runoff we can calculate and runoff curves. Then develop the river geometry. We add the input data as a river geometry, use the Hecross model and calculate the hydraulic parameters, that is water level and discharge. Then also we can compare with the sub-computing techniques like artificial neural network, computer model, and we can compare whatever the data generated through the model, theoretical model or physical models, and also observed data, compare with the observed data, as well as again the advanced techniques like artificial neural network. So ANN model. Then after comparing that, we see the how much variation, what is the future of prediction, next 100 years, next 50 years, next 30 years, what is the frequency of developing, occurring such type of events, and then what is the flow rate generating for time to time, that can be, will give the alertness in the features. So this is a software we can use by the any researchers, and they can generate the zone any type of data by using in that. So this is the HMS data by using component utilized provide to watershed physical properties of the calculated runoff through the loss transmission. So these are the blue lines are drainage line of watershed, and this is the watershed outlet, and these are the subcatchments. Each subcatchment has carrying capacity and the flow and flow depth. We can calculate each nodes, and then we join the nodes in the series components and carry forwarding the from one upstream to downstream, and routing from one nodal point to another nodal point by using HMS. So these are the masking some of the values we can calculate by using those data. The another component, the methods we can use by comparing the data, that is ANN, artificial neural network. So the feed forward batch back propagation, artificial neural model also used, have been used to simulate the discharge and compare with the across output model. So final result of the data of land use land cover, how the land use land cover varies with the time to time. So this land use land cover, the 2008, the LULC is the present, and after 2017. So this is available data based on the card resource chart 2 lease 4 image, and the 5.8 meter and 2 meter imagery we purchased from NRSC, and these data we analyze, calculate the land use land cover, and given the value of roughness, how the built up area increasing day to day, year to year. Last 10 years drastically it increased. All the area is converted into built up area. So see the various percentage of imperviousness is converted into perviousness calculated in the 2008 and 7. So compare the impervious is a blue and red is impervious 17, and impervious pervious in 2008 and 2009. See the always blue, yellow and green lines are always greater than none. So year to year is increasing the pervious line in most of the watershed catchment areas. So rocky area, this is the model output. So the study is hourly rainfall, observed flow data from the period of September to October 2020. That is our October floods. Especially we simulated the major, Hyderabad is a major loss on October 2020 flood simulated area, that we have simulated the two events, the October events 13, 14, 15 of October 2020, and also carried out the sensitive analysis and important steps model, which are helps to identify the most sensitive parameters and perform the NAS circuit efficiency index and change the parameters value. So compare the simulated hydrograph with the observed hydrograph, generated the various sensitive parameters, range parameter value increased or decreased plus or minus 10 to 30 or maximum 40%. You see the percentage of change of runoff based on the sensitivity analysis, zone 12 watershed of parameters, but in the values, how it changes. So some parameters are drastically decreasing, deviations, and some parameters drastically increasing. So curve number and Muskingum parameters are increasing drastically. So this is another technique. So comparison from the observed and the simulated. So see the comparison of flow hydrograph between the simulated and sensor gauged observed data. Here is calibrated, blue line is the calibrated data and black is the observed data. So almost the simulated calibrated data is matching with the same HMS model and with the similarly generated observed data. So the sensitive analysis, there is a scatter graph simulated versus observed relationship is 0.76. So 76% is correlated between the data observed and simulated. Same value simulated by using ANN also, both here also almost the validation, both ANN and observed data is validating more than 80% is generating near to the reality observed data. So evaluation of other parameters, ANN and that is matching almost near to the observed values. So final conclusion and the feature sensitive analysis of the study indicated that input parameters as curve number, time of concentration, and K parameter values are more sensitive to less sensitive in the same order sequences. Heck HMS model used for runoff, rainfall runoff modeling in Zone 12 watershed of Hyderabad reveals the Nash circuit efficiency is 0.74, R square is 0.76, and P bias is calculated 0.11.52. Hence, this study indicates Heck HMS model hourly flow in Zone 12 watershed is simulated reasonably well. Among all trial performed, ANN also its architecture is the ANN feed forward back propagation model is representative model. This study area is also applied for this study and also calculated and tested for the training. 70% data used for training and 15% for testing and 15% for validation. So both all the data shows almost 80% reasonably well. So finally, this study suitably applied for evaluating the runoff process where diversified input are playing complex phenomena. AN also study supported to the Heck HMS and fine tuning applications across the comparison. So feature also we can need the more. Current study suggests that future we can plan extend the study to evaluate the model performance with the highest length of rainfall records, and the zone frequent flood prone zones should be identified, and reliable sensitivity parameters has to be used to test the performance evaluation. And also it suggested more number of rain gauge stations should be installed and calculated the rainfall intensity with the shorter duration, high intensity with the smaller areas, even with the smaller 1 kilometer radius, 2 kilometer radius. Also, we can calculate these data and we can present the accuracy, near the accuracy, real data, and say the. So HECRAS model is also, this is a capacity component of XR 2D flow computation and model 2D model control specification, 2D mesh generation and model simulation. So these are the remote sensing maps, layers, digital terrain model and 2D flow area and 2D models for different area. This is the same Begumpet zone, zone 12, Khairatabad and Kukatpalli Nala. So risk maps have been prepared for October 13, risk map of October 13, 2020 flood, and a risk map for 2 years return period. So see the how much area day by occupied by the required, how the flood is increasing day by day, which affected by the scene. So risk map for 10 years return period, 2 years return period, and so similar. And 25 years return period and 50 years return period. See the how area is increasing day to day mainly, and the maximum water level also boundary lakes increasing, nalas are reducing, the area lies between 200 meter to nala lakes boundaries are under medium risk, and area encroached along the nalas and lake boundary are under high to very high risk. So this is the so I'm ending with this. This is a few find outs which are presented in this study. So this I am stopping this presentation is here. Thank you very much for giving this opportunity, and over to the chairman, sir, for the concluding in this.
Thank you, sir. Thank you for your wonderful and such a nice presentation. I think everybody has really enjoyed this thing. Really, I enjoyed, sir. Sir, I have small question, sir, if you don't mind.
Please,
sir,
please.
Every year, floods are coming. Every year, we are also having a lot of talks like this in our institution, in SK and other even professional bodies also. But how much quantity is increasing every year of the flood, or whatever the measures taken by the government, whether it is sufficient to meet these type of sudden flow of water and almost flooding every part of especially the Hyderabad town. So do you feel the measures which have been being now, because whenever the floods is there, suddenly government will keep announcing in TVs and newspapers everywhere they have elected this man, that department, this department. In spite of all that, there are a lot of the disturbance for the human life during these floods. So, do you feel, sir, some more measures? What type of measures can stop this excessive water, sir?
Yeah, it is a continuous problem, sir, because now last few years, because only the frequency of intensity of rainfall increasing year by year. So that is, it is now last 1 week, we don't have any much extreme rainfall event. It is less than 2-3 centimeters, 5 centimeters, 6 centimeters only. When we consider the rainfall more than 10 centimeters per 24 hours, that rainfall we consider the extreme rainfall. But what is happened day by day, we are reducing the carrying capacity of the nala. That will affecting the people's life. So that maintenance, what government they are doing only last 50-30 years, whatever the drains have designed and carrying capacity of that, when the population, suppose the 1908 flood, that time population was less than 5 lakhs. But almost they lost almost 80 people or 30-40 people, they lost their lives, and 80, more than 80 they injured. So that after that in 30s and 50s, the population slowly it increased, and up to 80. After 90, the population is increasing drastically, and whatever the drainage, the carrying capacity of the nalas which have up to 90s and 50s, those nalas, that carrying capacity has reduced now. And that was and catchment area was totally the infiltration capacity, which has holding capacity, water holding capacity, major water holding capacity of the rainfall is subsurface area. So subsurface area is totally decreased. Now total up to even 50-kilometer radius of, if you take central point of the Hyderabad or the Imliban, or you measure 50 kilometers radius, is totally paved. So there is no infiltration holding capacity of the surface. So total whatever the small rainfall event it occurs, it soon comes towards the downstream. So now the major severe action should required from the government side. First, they should clear all the bottom neck nalas, and desilting, all carrying capacity is drastically reducing. Total people are dumping their daily waste in the daily by daily basis. So there is the desilting in that. Now the SNDP has created by the government, and they are doing some only just nala foot over bridges, not for the nala cleaning. They should start with the nala cleaning and increase the retaining wall both sides to increase the carrying capacity of the drain. So that is the action should be taken, not for the covering the top surface covering. So they are foot over bridges, and that wherever damage, that some initiation is taken care, that is a positive sign. But they should create the nalas and first calculate carrying. First risk analysis has to study. Who are the technical people involved in that nala SNDP? Who are the people suggesting to do this? Nobody is there. So I submitted one report in 2020 that is put is on dump. Nobody has read just I and myself, Ramananayak Sahab and Director Rameshwar Garu, we had a meeting with our Vinod Kumar sir, and we submitted that some short-term measures and long-term measures. But they are doing, but a solid a solution is not coming out from the agency, so that has to be seriously think. And radial nalas has to be created, because they, without obstructing any nalas, crossing nalas, direct upstream to downstream wherever it feasible, some radial nalas should be created, and maximum carrying capacity water should be drained through the radial nalas. So these something new proposal should come and start the initiation immediately. Then only we can protect the urban dense population areas majorly. So this is the required for immediate action, sir.
Thank you, sir. Thank you for your very elaborative answer. But I would like to put one more factor.
Yes.
Don't you consider that the rampant construction of unmindful buildings, means wherever space is there, simply they are rising building, that is
Yes.
causing, also aiding to the cause of these floods, sir?
100%, sir. That all they are converting natural nalas to the paved nalas, totally paved surface, and all the on nala adjacent to nala, on the nala, they are constructing high-rise building.
Man-made mistakes, sir. Man-made mistakes.
So that has to be reduced. The permission should not be given. Then there is a coordination. Again and again, I many meetings I told that without coordination of GHMC, Revenue Department, Lake Department, Metro Water Works, R&B, Traffic Police, you cannot solve this problem. There is a coordination between all the department and give a single permission with the clearance of this. So like that only, why the only high intensity is impact on the national tributary, green tributary bit, why they are not giving permission to construct dam? How much risk is there involved to permit take? Similar thing it is also required for nala or houses construction. So that some body should be there, a solid organization. This bodies are there, but their coordination is required.
Thank you, sir. Professor Ramana Nayak has raised the hand.
Sir, highly acceptable talk. Professor Gopalji, highly acceptable talk. But recently we have seen atmospheric rivers in the atmospheric rivers. See, once upon a time the waterfall is so this thing 10 centimeters, 12 centimeters. But now Moranchapalli, we have seen Moranchapalli and some places. And the atmospheric rivers formed in how the Mississippi water taken place. You have seen in ETV and TNews also, of course. And SNDP strategy in order program somewhat better than previously. I think it's a damage.
SNDP, they are taking care. SNDP should act with the stringent, with the solid solution, and they can take the pilot project any one area. One area, they should clear all the nalas rising retaining wall. First construct retaining wall, improve the carrying capacity of throughout the nala, not the wherever the cross section is there, wherever the neck bottleneck. They should think about the starting point to ending point, clear the nala, drain capacity, and raise the retaining wall at the certain height, and all bottom neck unwanted construction has to be removed. So that has to be seriously taken care by this SNDP. They have to act on that.
Highly acceptable talk. Hanumantyar Sapu and Kondalrao Garu, ISNR are there. Very highly acceptable talk, sir. Thank you. Thank you, Professor.
Thank you very much, sir, for giving this opportunity.
Sir, thank you very much, Professor Gopal Nayak, sir. Anybody else has any question? Because some more meeting to be conducted by 6 o'clock already. We're delayed by 15 minutes. There is anybody want to ask any question? Shall we go ahead?
Yes, no, just one.
Dr. Hanmantacharya.
Yes, sir. Yes, sir. You see, first I want to compliment our Dr. Nayak for excellent presentation. But request Chairman Saab that let us have one workshop on this at the earliest, so that this is the right time to do. And many people have many questions. Many people have many answers. So let us try to put together and put to the government. This is only my submission, sir. So once again, my compliments to Dr. Nayak for the excellent presentation. Thank you, sir.
Thank you. Thank you, Hanmantacharya Saab. Thank you so much. Yeah,
hello.
Hello.
Sir, I request Dr. Hanmantacharya Garu to kindly take a lead and put, sir, we will.
Sure, sir. Wonderful. Certainly I will take up, sir.
Yeah. Thank you, sir.
Yes, sir.
We'll take the help of Gopal Nayak Saab and other eminent
yes, that's right.
planners who can let government realize there is something going on here. And
sure, sir, I am always be there as a FIE of IE Institute of Member of Institute.
I know, sir. I know you're very proactive to us,
yes,
and we really thank you for really the moment we called you.
Sir,
Instantly, without a minute thinking, you agreed for our this fact. We are very really grateful to you, sir. Thank you very much, sir.
Hello.
Any more questions, please? Kondalrao Garu.
అందరికీ నమస్కారం అండి. గోపాలరావు గారు చాలా చక్కగా చెప్పారు, చాలా ఎలాబొరేట్ గా చెప్పారు. ఈ జియో స్పేషల్ అప్లికేషన్స్ కూడా చేశారు. సో దీంట్లో ఒక చోట ఏమన్నారంటే ఆయన పర్వియస్నెస్ ఇంక్రీజ్ అయిందని చెప్పారు. సో జనరల్ గా ఓవర్ ద పీరియడ్ ఆఫ్ 2008 నుంచి 2017-18 వరకు పర్వియస్నెస్ ఇంక్రీజ్ అయిందన్నారు. హౌ ఈజ్ ఇట్ పాసిబుల్? బికాస్ ఆఫ్ అంటే కంటిన్యూస్ గా పేవింగ్ ఇంకా ఇంక్రీజ్ అవుతుంది, కానీ మనకు పేవింగ్ ఇంక్రీజ్ అయినప్పుడు పర్వియస్నెస్ ఇంకా తగ్గుతుంది, కానీ ఎలా ఎక్కువ అయింది? That is one point.
Pervious increase కాలేదు సార్, ఇంపర్వియస్ ఇంక్రీజ్ అయింది.
అదే దట్స్ జస్ట్ నాకు
ఇంపర్వియస్ పర్వియస్ డిక్రీజ్ అయింది.
అదే దట్స్ పాయింట్, దట్స్ వన్ పాయింట్. తర్వాత ఇప్పుడు క్లైమేట్ చేంజ్ కన్సిడరేషన్స్ ఏమైనా తీసుకున్నారండి మీరు?
క్లైమేట్ పారామీటర్స్ తీసుకున్నాం సార్, అది ఇంకా స్టడీ జరుగుతుంది దానికి ఇంకా దీంట్లో.
Because that is the major issue which is impinging on the situation.
దాన్ని ట్రెండ్ అనాలిసిస్ చేస్తున్నాము ఫర్ క్లైమేట్ పారామీటర్ ట్రెండ్ అనాలిసిస్. దాని నుంచి ఇప్పుడు మళ్ళీ క్లోజ్ చేయాలి ప్రాజెక్ట్.
తర్వాత రిటర్న్ పీరియడ్ ఎంత తీసుకున్నారండి? దానికి కరెస్పాండింగ్ రెయిన్ఫాల్ ఎంత తీసుకున్నారు మీరు? అంటే వాట్ ఈస్ ద రిటర్న్ పీరియడ్ యూ సజెస్ట్ ఫర్ ద సిటీ అండ్ ది కరెస్పాండింగ్ రెయిన్ఫాల్?
ఇప్పుడు రిటర్న్ పీరియడ్ అంటే ఇప్పుడు సార్ లాస్ట్ 30 years అప్పుడు 70s లో వచ్చిన 90s లో 90s తర్వాత 2000 తర్వాత 2004 2008 2012 14 16 ఇట్లా తగ్గుకుంటూ 10.
Professor Ramana garu, kindly mute your this thing.
Yeah, two years. Now we are expecting every year such events, sir. That is the trend is following because of this global warming and climate change impacts. So patterns is changing year to year. So
అంటే ఎంత rainfall అంటే corresponding to 1 year return period, how much rainfall you are suggesting అండి, అంటే based on your study?
మనకి ఇప్పుడు ఎక్స్ట్రీమ్ రెయిన్ ఫాల్స్ అనేవి ఇయర్లీ ఒక 2-3 వస్తాయి సార్, అంతకంటే ఎక్కువ రావు.
అదే అంటే మనకు డిజైన్ రెయిన్ఫాల్ for the return period of 1 year, how much you are suggesting?
We consider the data from last 79 to till 2020, sir.
Wonderful,
2020.
wonderful.
So this data we have considered doing. Now we are doing next 30 years projecting now. So how many that we are studying on that?
అంటే what is the rainfall you are suggesting? అంటే maybe 30 mm per hour లేకపోతే 50 mm per hour, what is that you are suggesting?
ఇప్పుడు ఈ 10 ఫ్రీక్వెంట్ రెయిన్ ఫాల్స్ అనేది మనకు రేంజ్ జస్ట్ 10 సెంటీమీటర్ బిలో 20 సెంటీమీటర్ అనేవి చాలా ఇంక్రీజ్ అవుతుంది, ఎవ్రీ ఆల్టర్నేట్ ఇయర్ వస్తుంది సార్. కానీ 30-40 అనేవి రేది ఒక 5 years పీరియడ్ 10 years పీరియడ్ లో ఒకటి తగులుతాయి అట్లాంటివి.
Thank you, sir. Thank you.
Okay, thanks a lot.
Our good friend from Jharkhand, engineer Shivanand Rai Saab, he has raised his hand. Sir, anything you have, any questions, sir?
No question, sir. I appreciate your this talk on the very pertinent subject. In talk, what I could get, that story of Hyderabad is valid for every city in India.
Yes,
everywhere there is problem due to the main problem is no cooperation between the engineering departments, the town planning, the water management, the sewage management, the road department, and all that. So to have a good cohesion between these engineering departments, we need to have work on with III, and I request Telangana State Center to organize a all India seminar on this issue at Hyderabad.
Yes,
So people
Definitely,
from
sir.
all affected states may come, cities may come and deliberate on the issue, and we have to take care that all the departments, what we do, the construction goes on one side, destruction goes on other side, nalas are enclosed. Everywhere this is the problem, and we have to address it, and the institution of engineers shall take it up, and Telangana State Center, I request to arrange one seminar on this issue, workshop, not seminar, call it a 2-day workshop. Sit together and try to work out how we can get through this hurdle. Thank you, sir.
Thank you, sir. Thank you for your nice suggestion. We will definitely take up and make a big 2-day all India seminar on that.
Yeah, 2-day workshop maybe.
Workshop, sir. Workshop will be better. Seminar is workshop is good.
Okay, sir. We take your suggestion well, and definitely we'll try to do that in very near future. So anybody else, or shall we close?
Sir, namaste, sir.
Yeah,
Sir, namaste, sir. Sir, can I share one thing, sir?
Yeah, please.
Actually, sir, I am staying in Manchirevla area, sir. A year back, we shifted there by purchasing a 3-bedroom flat, sir. So, I just wanted to express one problem, sir. because whenever the Swan Sagar water is released through the Musi River, our service road will be submerged always, sir. Last year we experienced this thing. So recently, one exit 18A also has come parallel to the service road, sir. So whenever there is a overflow from the Osman Sagar Dam, the whole water passes over the service road. So actually, there are a lot of encroachments, sir. And as you said, as Professor told, there is a lot of vegetation in the Musi River, which has to be removed. So, and encroachments also are there, sir. They are also to be taken care of. Then only the problem will be solved, sir. That's all, sir. I wanted to share this problem. Thank you, sir.
Sai Ramanaji,
Thank you, sir,
good.
for giving opportunity.
Okay, thank you very much, sir. And I'm really happy with the talk, and the sir has shared a lot of valuable and wonderful information, useful information, which is to be put in practice. Now I request our Honorary Secretary Garu, Dr. Venkata Subbai Garu, kindly to propose vote of thanks.
Thank you, sir, Chairman, sir. So it is my pleasant duty to perform vote of thanks. Engineer B. Brahma Reddy, Chairman, IA Telangana State Center. Eminent Speaker, Dr. Gopal Nayak, FIE, Professor, Department of Civil Engineering, University College of Engineering, Usmania University. Engineer T. Venkatesham, the Joint Honorary Secretary and also the convener of today's event in his absence. Council members, Engineer Sivananda Rai Garu, Dr. I. Satyanarayan Raj Garu, past Chairman, Dr. D. Hanumantachari, Professor Ramna Nayak, Dr. G. Rameswar Rao, committee members, Engineer K. Subbireddy, Engineer Saripalli Suranarayana, corporate members, G. Sushil Kumar, Dr. P. Narayana, G. Kondal Rao, family members of Engineer A. P. Ranganatha Swamy, distinguished guests, representatives of media, ladies and gentlemen. On behalf of the Telangana of III and on my own behalf, I convey our sincere and profound thanks to Dr. FIE, Professor, Department of Civil Engineering, Usmania University, who delivered a wonderful lecture with the title Real-Time Urban Flood Modeling Using Ultrasonic Sensors and Geospatial. Thanks. So once again, I extend my heartfelt thanks to you, sir, Gopal Nayak Garu.
Thank you.
I would like to express, thank you, sir. I would like to express my gratitude to past presidents of IEI, past chairmen and past honorary secretaries and corporate members and committee members of IEI Telangana State Center, council members, representatives of media and others who made it convenient to attend this event. Thanks to one and all. Now I request all of you kindly stand for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन मंगल दायक जय भारत भाग्य विधाता जय हे जय 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 हे
जय हिंद।
जय